So the moment arrived, the end of the 5th EVA, we'd done everything. We'd accomplished all of our goals, all of the instruments. We'd even put on the extra insulation on the outside of the telescope. And to my great surprise, in that moment when I gave Hubble one last little pat and a salute, I wasn't sad at all. I felt really happy that we'd accomplished all of our goals, we'd done our job and a little bit more, and we were sending Hubble off in the best shape of its entire career.
Orbiting 375 miles above Earth is a most extraordinary scientific tool that has forever changed our knowledge of the universe. The Hubble Space Telescope is one of the greatest technological achievements in human history. For 20 years, the world has marveled at its astonishing images of our dynamic solar system and the many wonders beyond. Jupiter-sized exoplanets orbiting other suns, exploding stars and nebulas, massive exotic galaxies. These and other discoveries not only confirmed many scientific theories, including the existence of mysterious dark matter and star-devouring black holes, but also raised new questions for scientists to ponder about the origins of the universe and the endless diversity of the cosmos. Since the dawn of time, we've looked skyward and wondered, how far away are those stars? And how many are there? How did this all begin? Are there other worlds like ours out there? It was only 400 years ago, a mere blink in the cosmic timeline, that Galileo first observed rings and moons on our neighboring planets, Saturn and Jupiter. This forever dispelled the myth of Earth as the center of everything. Modern astronomy was born. As centuries passed, telescopes became larger and more powerful, able to observe far beyond the limits of our eyes. In 1924, from atop Mount Wilson, California, the astronomer Edwin Hubble first observed that the universe is made up of billions of galaxies, extending well beyond our own Milky Way. Hubble observed that distant galaxies appeared to be rapidly moving away from us. Using known stars to calculate distances between galaxies, Hubble confirmed their retreat. In 1946, the acclaimed astronomer Lyman Spitzer proposed building a large telescope to orbit the Earth. Free of the atmosphere's blurring effects, it would deliver images in brilliant new clarity.
You always need visionaries who can look out into the future and think about what's possible. And the motivation that Lyman Spitzer and others in his footsteps had was about getting above the Earth's atmosphere.
While Spitzer's idea was well received by astronomers, it would be more than 30 years before funding was granted to begin the design and development.
It took time for the technology that people had to catch up to Lyman's initial conception.
Named in honor of Edwin Hubble, the orbiting observatory's construction began in 1978 with the creation of an enormous, nearly 8-foot mirror to gather light from objects across the universe.
That's kind of the heart, the soul of a telescope. It's the thing that collects the light. Without the mirror, you don't have a telescope.
When completed, the Hubble Space Telescope would contain a wide field and planetary camera, a high-resolution spectrograph, high-speed photometer, a faint object camera and spectrograph, all capable of beaming real-time data back to Earth for analysis by scientists. And all contained within a spacecraft as large as a school bus and weighing more than 12 tons. Hubble's journey finally began on April 24, 1990, at NASA's Kennedy Space Center in Florida, aboard Space Shuttle Discovery.
Roll program.
After a shuddering, bone-jarring launch, Hubble and its precision instruments was gingerly placed into orbit.
I remember the crew talked for months leading up to the flight about what the significance of the flight was going to be. There was a lot of conversation back then among the scientific community about the Big Bang Theory And there were those who believed that Hubble would provide all the answers. Among the crew members, we thought that Hubble would provide lots of answers, but that it was probably going to revolutionize the field of astronomy and astrophysics.
Light from the objects it studied would be focused onto Hubble's giant mirror, then converted into data for downlink through a communications satellite to 60-foot microwave antennas at White Sands Test Facility in New Mexico. From there, the data would be relayed to Hubble's Operations Center at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and on to the Space Telescope Science Institute in Baltimore for dissemination to scientists worldwide. Now that the telescope was deployed, the promised brilliance of its photography had astronomers eagerly anticipating Hubble's first images. What they got were pictures rendered useless by a fuzzy halo around each of the sighted objects.
We expected that we would have to make adjustments to make the images as clear as possible. But as hard as we tried, we could never get all of the fuzziness out of these pictures.
Finally, everybody kind of got around the table and said, we've got serial aberration, and we cannot do anything on the ground to correct it.
While we were confident in the assessment that was given by the scientists and the engineers, I always had this nagging feeling that we may have done something in our real struggle to get Hubble out of the payload bay that had contributed to the problem.
The primary mirror had been polished perfectly, but to an incorrect prescription. A repair plan was needed. NASA engineers focused their expertise and came up with what they believed was the solution. December 1993, STS-61 astronauts delivered to Hubble a new wide-field planetary camera with a set of internal mirrors that the telescope would wear like a new pair of eyeglasses.
When we started out on this mission, the STS-61, all the failures had not happened. We're redesigning the mission as more things fail. And they were contemplating splitting our mission up, thinking we couldn't possibly get all done what we got to get done, and there's more failures happening.
The miracle on the ground was getting it all done and getting it onto the shuttle on cost and schedule, and then the miracle in space was for the first time ever servicing a satellite with 5 EVAs and having every single spacewalk go perfectly. And then it all culminated what could only be called the day of vindication.
This time, the images disappointed no one.
It took years, but I finally breathed a sigh of relief that I had not been one of the causes of Hubble's fall.
The newly restored Hubble was ready to work. Just 9 months prior to Hubble's successful servicing, 3 astronomers at California's Palomar Observatory had discovered a comet whose enormous fragments now appeared to be on a collision course with the planet Jupiter. For Hubble, it was a golden opportunity to watch as the gas giant's atmosphere was blackened and scarred, then racked in seismic waves by planet-sized chunks of the comet. With almost every new observation, Hubble was rewriting the science books and raising new questions for astronomers. Over time, NASA would send 4 more shuttle crews to service and upgrade the Hubble Space Telescope. In May 2009, STS-125 and its Space Shuttle Atlantis crew performed the 5th and final servicing mission. Upgrades, repairs, and new equipment would give Hubble a new lease on life.
It's just really a wonderful experience to be there and be inside or outside of the telescope looking at it with the Earth in the background. Working during a spacewalk is really quite a privilege. So those memories are the most vivid ones that I have.
This was mission specialist John Grunsfeld's 3rd visit to Hubble. On his 6th spacewalk, Grunsfeld became the last human to lay hands on the telescope.
So it's this synergy between the humans and the design of Hubble to be serviced that has really given us not one Hubble Space Telescope or one observatory, but many observatories each time we visit it and reinvent the telescope.
Hubble really is an amazing example of the way people and robotics works together in space. Hubble is up there without people operating it in space every day, taking these great observations, and yet it benefits from having people come to it and inject new technology. So it's not a 20-year-old telescope, it's got brand new technology.
I think it's a real lesson, and one of the legacy products of Hubble is that throughout this servicing series, this incredible series of 5 servicing missions, Hubble has done nothing but get immensely more powerful.
With Hubble, our neighboring planets now reveal themselves in never-before-seen clarity.
Giant gas planets like Uranus and Neptune, they sound large and they are large, but they're very far away. And to ground-based telescopes, they are small disks of light without a lot of detail. Hubble really zooms in and shows us quite a bit of detail on those planets.
Surrounding us, we now see billions of galaxies in every shape imaginable, millions of light years across.
It's a single point of the sky. We stared for 10 days at a single blank piece of sky, no more than a drinking straw. So you look up at the sky, look through a drinking straw, and we found 10,000 galaxies in that single pinpoint of dark sky. 10,000 galaxies there. Some of those galaxies have been around, their light has taken 13 billion years to reach us.
Hubble's imaging of exoplanets circling nearby stars provides direct evidence of new planet systems under construction. Hubble has given us new insights about how stars die and how they are born. Hubble's discovery of a supermassive black hole in the center of galaxy M84 has led astronomers to conclude that an immense black hole is at the center of most galaxies.
What we did was we put the spectrographic slit of this instrument down right on the core of this elliptical galaxy M84. So what we're looking for is the signature of a black hole. What happens there? What happens in that environment? Well, usually what happens is there's a ring of gas in a very tight orbit around that black hole. And that ring of gas is rotating very, very quickly, of course, because the black hole mass is huge.
One way to recognize the presence of a black hole would be to measure its influence on the stars and gas that are close to it.
Hubble has greatly contributed to astronomers' knowledge of dark energy and how this mysterious, little understood phenomenon is speeding up the very same expansion of the universe discovered by Edwin Hubble decades before.
What everybody believed was that the universal expansion was slowing down due to gravity. I mean, it made sense. There's no anti-gravity that we know of, but there is now.
In Hubble's 20 short years, we've learned more about our universe than in the nearly 400 since Galileo first peered into his modest telescope. Hubble's last servicing mission marks the telescope's new beginning. More powerful than ever, it will lead our exploration of the cosmos for several years to come.
To come to the end of that time and release Hubble and think, you know, everything we came to do got done, made me feel really proud about the whole team, the way we'd worked together, hopeful for the future with Hubble that everything we'd done actually worked and when they checked it out, and just thinking about what Hubble could do now that we'd given it a new lease on life. It was very rewarding.
Not many humans get to work on things that 100 years from now, history will remember. Hubble is certainly one of them.
The Hubble touches people not only for the science, but it touches people for its aesthetics and its beauty. And the people that choose what to study have done the right thing. They've done an extraordinary job of not only getting great science, but also the beauty of the universe.
400 years from now, they'll look back and they'll say, well, the Hubble really did change the way we see the universe.
I think the scientific legacy is that textbooks have been rewritten because of Hubble. I think the fact that we didn't know 20 years ago about black holes or exosolar planets or galaxy evolution, dark energy, we didn't know we could measure dark matter. I mean, we're at a point in our history where we have now discovered we only understand 4% of the universe. The rest of it is completely unknown.
Waiting in the wings is NASA's Next Generation Telescope. When it is launched in 2014, the James Webb Space Telescope will soar deeper into space and look even farther back in time to unexplored territory at the beginning of our universe.
And the Hubble has shown us, if you like, the peaks of the iceberg, those very first galaxies. The James Webb Telescope is going to penetrate right into what we call these dark ages, where those very first galaxies are probably lurking, out of sight from us currently.
The Hubble telescope has made a remarkable journey, from imagination to reality. It has not only transformed the way we view the universe, but also fundamentally changed how we view ourselves, our place in the ever-expanding cosmos, and the never-ending journey before us.